creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Gary, what I have here is a ROM chip in this cartridge, and I'm going to take this ROM chip and stick it inside this machine and load it in there and press a couple of buttons, and if everything works according to plan, this is an example of computer music, and computer music is our subject today. This little RAM pack, which I have over here, has 15 songs on it. Matter of fact, there's a ROM Chip of the Month Club now where you can buy your popular songs on a chip instead of on a cassette tape or on a record. This is a simple example, but how does a computer make music? How is it doing this?
Well, as you're aware, Stewart, this is a very special device. It's not a general-purpose computer. But most of the home computers that are available now, like the Commodore 64 or the IBM Personal Computer, have special hardware for sound generation or tone generation. And what you do is you write a program in BASIC or Logo or one of those languages, if you like, and then you can produce tones, series of tones, and certain frequency and duration. And I understand there are also some software packages coming about that are like word processing packages, only it's for music processing or score processing. And it's going to be interesting today, I think, because we'll have some real experts that will tell us all about it.
Indeed we will. We'll be meeting Will Harvey, the author of Music Instruction Set. We'll see a demonstration of the Alpha Centauri music system. And there are two major centers for computer music in the country, one here in Northern California at Stanford. We'll be meeting the director of the Stanford Center later on in the program. First, let's go across the country to Cambridge, Massachusetts, and a visit to MIT's Experimental Music Studio. The use of computers in musical composing is not a new idea, but recent advances are giving composers a new degree of power over their medium, the ability to create and manipulate sound waves of their own design. Systems like MIT's Music 100 can dissect a note into its sound wave components. The composer can then make adjustments to each aspect of the note's physical characteristics independently and instantly. Specially developed music languages translate the sound processing as specified by the composer. From this input, a digital data stream is computed. Finally, the digital form is translated into a signal for amplification, pre-recorded, and played back over audio tape during the performance. A computer that can reassemble the building blocks of a sound wave opens up a new spectrum to the composer and the musician, a range of sounds beyond the natural limits of mechanical instruments and the human voice. In a sense, the music program can compose not only the score, but the instrument as well. The next step in computer-composer interaction is real-time production synthesis, a live interactive performance between computer and instrument. To achieve this kind of instantaneous but programmed manipulation requires very high-speed computers capable of several 100 million calculations per second. Okay, joining us now is Will Harvey. Will created Music Instruction Set, a hot piece of software being offered by Electronic Arts right now. And John Chowning. John is director of Stanford's Center for Computer Research in Music and Acoustics. Did I get that right?
Right. Karma, we call it.
Karma. Gary.
You know, I was just going to mention, I think with that Casio tone, I finally found an instrument that I can play.
I think we have some more here.
Right. John, I think it'd be worthwhile just to talk for a minute about the state of computer-generated music. Where are we at today?
Well, it's, I guess, nearly 20 years old since Bell Labs engineers and scientists first conceived the idea. And what's happened in the recent years is evident in things like personal computers, and that is large-scale integration. And what that means specifically as far as computer music is concerned is that we're getting more and more power in smaller and smaller units, which means that what was once in the lab now can be put in concert hall or into smaller environments.
Some purists, John, and maybe Will, you could talk from your end on this too, think that computers and music is somehow wrong and somehow depersonalizing composition and creativity. What role really does the computer play in computer music, John?
Well, a computer, of course, being based upon programming languages, is really an access, I think, to a mode of thought or a body of thought that really represents, I guess, tens of thousands of man-years of thought about thought. And I think that's the significant difference between computers and music and electronic musical instruments of the preceding years. That is, as soon as a computer language is involved, one has access to a degree of power and generality, which was certainly not the case in ordinary electronic musical instruments. I mean, look what Will's done here with a personal computer and a programming language and a considerable amount of imagination. So it really doesn't depersonalize music, I think, but rather maybe humanizes computers, I guess I would.
Do you think it helps with the composition process of just composing music to be
Of
able
course.
to have that interactive?
Sure.
nature?
I think a programming language is such an enormously rich resource that it must, at any level, enhance the compositional process.
Will, you guys are different ends a bit. John is working at Stanford with a big mini and a complex operation, and you're selling a $40 software. From your end, how do you see computers and music meshing? I mean, how did you get involved in this combination?
I think computers are a way that people can be introduced to music. And with this program, what we tried to do is allow a person who doesn't know anything about music and who might be intimidated even by it to go out and to fool around with music already created, or to create his own, and be able to do everything just with a joystick.
Maybe you can show us a little bit about how a music instruction set works.
Okay, well basically you're moving around with the joystick a little hand, and that hand represents your hand. So in order to create music, what you do is you move your hand around and you pick up notes and you set them on the staff, which you see there. After you get the notes set up on the staff, you can move to one of these little pictures here, and the pictures do things. For instance, if you want to play the music, you go to the little piano, which is there. Or if you want to go to the home position, which is at the beginning of the song, you go to a little home and press the button. I've got a piece here that is included with the product, and so I'll move the hand down to the piano and press the button, and it'll play through the piece. Then going to the home, we can go back to the beginning of the song.
The notes going across the staff are showing us the music that the computer's playing at the time.
Right. Basically, it's tying together what it sounds like and what is on the screen. So it's like having sheet music in front of you that scrolls right past your desk. Whereas with the sheet music, you can pick up your pencil and eraser and erase notes and change them or move them around, or even pull out the scissors and cut and paste in different areas. With this, you can move your hand around, pick up a note, move it somewhere else, and drop it. If you want to sharpen a note, you just pick up...
And what you did is press the button to hear what the note on that particular place sounds like.
Right. Actually, I dropped the note, which actually changed the music that's in there right now, so if I played this, it wouldn't sound very pretty. It also tells me what that note sounds like, so if I were composing music, for instance, or just wanted to know where it was, I could tune my ear.
Certainly makes learning about music a lot more fun.
A lot of fun. You can start out, instead of having to learn to play an instrument, you have to learn to use a joystick, which isn't all that difficult. But you can start out by taking Mozart or Bach and then fooling around with it and changing notes and seeing what it sounds like.
What's your experience with people that are first playing around with this? Do they like to learn about music because of this interaction?
The first thing whenever they see a new computer program is to be overly cautious. So they'll move around the hand and be very careful not to move a note too far, this or that. But it doesn't take too long, maybe 5 or 10 minutes, before they realize, hey, this is fun, I'm not going to kill myself if I do something wrong.
Will, you said this program is for people who don't know too much about music, but yet you said you've got to take a note and place it on the staff, and a person who doesn't know much about music doesn't really know how to do that, does he?
Well, as far as moving a note around, the instruction manual tells you what the staff is and some of the basic music notations. you are required to be able to move around notes, move around the hand, pick up and drop notes, but you don't have to know if this is an A or a B or a C sharp or what. For instance, I can point to this position here. I'm pointing to that note, and I could say, well, what am I pointing to right now? And press P. And it plays the note. It says I'm on D. And it also says down here, you're sitting on note D. So it correlates the position on the staff of a note, the sound of the note, and the letter name of the note, which is a novel idea.
Mm-hmm. John, briefly, how would that compare with the kinds of things you're doing at Stanford?
Well, let's see. We assume, for example, in our environment that these abstract symbols notation have already been learned. I mean, our activity is really centered around musicians who have studied for some considerable time, and engineers and psychoacousticians, for example. And our interest in notation is maybe at a slightly different level, having to do rather with music manuscripting, and perhaps later we can talk a bit about that. But I find this very interesting because it's as Will has pointed out, it's a very accessible medium, and through which one can learn a rather abstract and difficult sort of language, if you will. I mean, music notation. I think that's good.
Okay. In just a moment, we're going to take a look at a reasonably sophisticated device which you can plug into your computer, the Alpha Centauri system, and that's coming up next. With us now is Ellen Lapham. Ellen is president and co-founder of Centauri Corporation, the people who make the Alpha Centauri computer music system. Gary?
Ellen, what you have here seems to be somewhat different from Will's previous demonstration. How does what you're doing differ from the music instruction set?
Well, we're both in the music business, and we're both, in fact, using computers to do things that are musical. The key concept behind Centauri and what we do with music, simply music, is turn it into a musical instrument, a live musical instrument that you can play, you can listen to, you can transform sounds with, you can design sound, you can compose, and you can even learn keyboard. So what I actually can show you today is a program we call Simply Music. What I'm looking at on the screen here is a list of albums. Just as I have a 45 RPM record on my player, or 33, so I have a diskette. It goes into my disk drive, and now when I do a directory or catalog, I can see the list of songs I have previously recorded or someone else recorded loaded in. Why don't we listen to Jesu? Now, I played that piece in a couple of weeks ago, or someone else did, or perhaps you played it in yesterday. If you're learning to play keyboard, though, listening to music is not just what you need to do. You also need to see what's going on. So we're using the power of the computer now to give you a keyboard instrument that you can play and listen to, give you a video screen that shows you the music you're playing, and if you don't know how to read music, I will help you even further. I can load in a display of the keyboard itself, so that when I play back Jesu, I can see the parts that were played. Now that's a fairly complex piece. If I were learning to play music, if I'd never approached a musical instrument before or a computer music system, I might choose a more easy to learn song. For instance, Merrily. Now this is a pretty simple song, but it gets the point across that you too can learn to play keyboard with this fairly fancy technology just by
That sounds like segue music, Ellen, and I'm going to take advantage of that music to turn to John for a second. And John, one thing, of course, you're dealing with a computer so large we couldn't bring it here in the studio at your Stanford location. One thing you're involved in is music notation. I think you have an example of that in front of you. Show us what that is.
Well, it's an extension of the same idea, and I guess demonstrates what one can do with an enormous amount of effort and over a large number of years. This is a program that was developed by Leland Smith, also on the music faculty, who over a 10-year period has refined the music manuscripting program, which allows one to use a standard printer plotter to output music in large scale then it's photo-reduced to become publishable quality. Well, the advantages are that his program automatically finds, does part extraction, finds page turns, and of course eliminates all the problems of error making in music publishing. So it's a contribution of considerable importance, I think, in the music industry. The same basic ideas, but reaching a very high degree of refinement.
John, okay, you've brought with you an audio tape from your system at Stanford. We're going to play that tape right now, and if you can put on the headset so that you can hear it as we play it, and tell us what's going on in this audio tape.
Okay, this is an example of high-quality vocal synthesis using frequency modulation synthesis. It took me about 6 months to find the little cues to naturalness that seem to be so very often lacking in most electronic music synthesis. Now, having worked out this algorithm, we can play the next example and hear an extension of nature into a slightly unreal domain. For example, I've modeled now the human voice, but of a very, very large man, so it's deeper than any real human being could sing, as if he had a 6-foot chest, I guess, and a 3-foot neck. So the vocal resonances are greatly amplified because we have this independent control over the dimensions of sound in its abstract form. Now, one of the most important things about synthesis, and which will accrue to devices such as this and the things that little synthesis algorithm that Will was using, has to do with using the technology in such a way that we have a very clear sense of what's natural sounding. The next example demonstrates first just a pure tone, which we'll hear, which is the pitch of what will become a sung vocal tone. Then in a few seconds we add all the harmonics or information that would be present in a real sung tone, but it only becomes natural at the moment we introduce the vibrato and this kind of wiggling in the pitch space, which is common to all natural sounds virtually. Once more, pure tone. Now harmonics, but not natural. And now it sounds natural, sounds vocal-like. So we can, by doing a vast amount of research and analysis in psychoacoustics and signal processing, we can extend to this miniaturization, which we see, a kind of quality of sound which I think will be a very great improvement.
Okay, John, we're going to move from Stanford now and go back across the country to Cambridge and MIT's Experimental Music Studio for a brief performance of a duet for piano and computer.
John, is the work that we're seeing in computer-generated music, is that still mostly in the laboratory, or is it being used in production now?
Well, I think with the large-scale integration, we're seeing many of the techniques that have been developed in programs, etc., over the years in the context of a lab, finding application now in industry. There are, music synthesis algorithms that can be implemented in large-scale integrated circuits. We'll certainly more and more find use in devices of this sort, and organs and synthesizers and who knows what else.
Ellen, you mentioned earlier the concept of your floppy disk as a kind of record album with titles on it. We saw at the beginning of the program this kind of ROM cartridge. Do you see a kind of new form of music publishing in which you could buy floppy disks for a computer playback system?
Absolutely. In fact, my floppy disk is my personal diskette. I can self-publish which means that now I'm a composer and a publisher all rolled up into one. That is, I have my Centauri, I generate my own music, I save it on diskette, and I can send it off to friends across the country or around the world. So now every musician and every student becomes a publisher, and that means also that the teachers become publishers of their own musical material, and the professional composers can also publish for the audience of people who have the same instrument. So absolutely, yes, it is a new form of publishing, but a very personal one.
Very quickly, we have about a half minute left. Do you find a resistance among professional musicians and composers, or they really love to get into this?
Well, I mean, at Stanford, virtually every composer who comes to study there not only learns about computer music, but becomes a rather exceptionally good programmer. So I think there's very little resistance, especially in the young generation. After all, people the age of is at will, the young man. Well, I mean, he's already beat the hurdle. You see, he already understands a great deal about programming because these things are in the environment, and that's good.
Okay, John Chowning of Stanford and Ellen Lapham of Centauri, thanks so much for being here, and thank you for joining us. We'll see you next week again on the Computer Chronicles.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.